Okay, here we go. Thanks for joining me, and we are doing Wireshark Wednesdays. This is our third session. We skipped last week because we were all at DEF CON, at least six of us in the ROUTERGODS group. And today is August 13th, 6 p.m., just after 6 p.m. Once again, we're aiming for 70 minutes, and that's because your time is valuable. We don't want to go on too much, 2 hours, 3 hours. Then you start losing your attention span. So your time is valuable, so is mine. So we're gonna keep it brief. And if I start getting close to 70 minutes, someone text me in the chat window, or you can turn on your mic and tell me, and that will serve as a reminder. Okay. Oh, someone got a LG widescreen. Very good. It's like 200 something dollars, wasn't it? Okay, the goals today, we're going to ramp up the difficulty just a bit. And the reason for that is we're going to be taking GNS3 with Wireshark. I know we've done that in the past weeks. And now we're throwing Kali Linux into the mix. So GNS3, Wireshark, Kali Linux, and most likely you're running it in VMware Workstation or VMware Player. In VirtualBox, if you like VirtualBox or prefer it, that's fine as well. We're going to be doing attack and defense. So we're going to be looking at how to attack CDP, possibly some defenses. We're going to be looking at Telnet, how to attack that. Because a lot of times people tell you, oh, Telnet's bad. Telnet's in plain text. Well, that's great that you've been told that in class, but you haven't actually seen it attacked in real life. So today we're going to be able to do that. Our standard disclaimers: this session is being recorded, and also the legal disclaimer: the opinions expressed here represent my own and not those of my employer. And of course, if you're using a Wireshark, make sure you Wireshark and sniff stuff that you are allowed to. All right. And let me paste the hackpad in the chat window again so the guys who just joined us can see. There you go. There's the hackpad so you can follow along. And for our announcements, any certification passes in the last week? Anyone pass CCNA, CCNP, any other tests in the last week? I guess it would actually be the last 2 weeks since we didn't actually meet last week. Nope, all right. Anyone got a new job lately? New job in the last 2 weeks? Or possibly in the running for a new job? Okay, not a problem. Let's see. The attendance today is much lower than before. It's about 15 people. In the first and second sessions, we had 50 to 70 people, so not sure what's going on this third one. Okay, topology today. It's going to be in GNS3. We're going to have router 1 and router 2. We're going to have a hub and the cloud. Cloud is connecting to VMware. And if you open up your GNS3, if you don't already have it open, it's going to look like this. Now the reason for this hub, basically the only reason for this hub is it gets this cloud connection, this VMware connection, in between router 1 and router 2. Right, so you can almost think of this hub as like a breakout hub, a tap, whatever you want to think about it. But this hub right here is a GNS3 thing that we have to do. Normally what it would be is, the way we would draw it is, we would have two routers. That's a horrible circle, right? Two routers directly connected, and then somehow we break the connection temporarily, put a tap, we splice it, put a dual com gigabit tap on it, and then we have our sniffer or other computer over here. Now in GNS3, we have a built-in Wireshark utility, and we can basically start it on any link. We could start it there, we could start it here, it's kind of pretty cheating because we could place it wherever we want. Right. Now, if you don't know how to set up the cloud is pretty easy. Once again, it's just an extra connection to the outside, to another computer. Now, in our case, the cloud is connecting to VMware Workstation, and I've got Kali Linux running inside of VMware Workstation. And the way I have this done is, if you don't know where the cloud is on GNS3, it's over here on the left side of the menu. You have to click on Browse All Devices. Click there, and then you've got this cloud icon in the bottom there. And then you drag it out. After you drag it out, you're going to right click on the cloud, configure, click on C1, and then under NIO Ethernet, that tab there, you're going to have a drop down of your interfaces. And if you've installed VMware Workstation beforehand, you should have something like VMnet 9, VMnet 8, different numbers like that. I pick VMnet 9. And then one thing that people forget to do is you have to click this add button, and it pops it in here. So a lot of people will click the network, they don't click add, they'll click OK, and they wonder, why does my cloud not do anything? So make sure you click add, click OK, then it's going to hook this cloud into that external interface. All right, I think someone has an open mic. There we go. All right, any questions about this GNS3 topology here? And then when you connect it up, always when you connect it, click on this icon on the left side, that Ethernet plug, and when you click on it, your cursor turns into a crosshairs. If you're given the option, always pick manual mode because that lets you choose the actual interfaces. Now this is the GNS3 side. On the VMware side, I'll show you how it looks. So right here we have VMware Workstation. To get that VMnet 9 interface, what you have to do is go to Edit and the Virtual Network Editor. Virtual Network Editor. You click on that guy, and it's going to think a little bit. And it's going to think and think and think. Dear God. Okay, there we go. Okay, so it's going to list these different ones. If you don't have this many, that's fine. If you don't have VMnet 9, just click Add Network. So VMnet 9, make sure you have it clicked on host only, not NAT, not bridge, because you don't want this network talking to the outside. You only want it talking to GNS3. And then click on connect a host virtual adapter to this network. So you're linking VMnet 9 to that interface. And you don't need DHCP on that one. Right? So you make VMnet 9 right there, make sure it's host only. And then on the actual VM, see, on the VM Kali Linux, you're going to edit the network adapter and you're going to hook this virtual machine to VMnet 9. So this custom specific virtual network, you're going to click the drop down VMnet 9. Okay. Any questions about the VMware Workstation or the actual virtual machine setting? And you can just power that guy on. And then just hit enter at the next screen. And everything will start up just fine inside of VMware Workstation. How many of you downloaded Kali Linux and have this pretty much already set up and connected to your GNS3 already? Yeah, VMware Player is just fine. Okay, and also on GNS3, you can click play and then open the console windows while we do the next section. Okay, so hit play, open up your console windows, and we have a couple minutes here to talk about some stuff. Okay, two things that people ask a lot is, we're using Wireshark inside of GNS3 and we can see the traffic. That's really awesome that we could tap virtually. But if I want to tap something in real life, if I want to sniff in real life, how do I do it? What do I have to buy? And where do I put this tap? Right? So when you're looking at taps, there's two things that you're looking for. Two terminology or two words or two phrases that you're going to see. You're going to see something called fail closed, and you're going to see something called fail open. What these mean is fail closed is if you put a tap, a gigabit tap, a hub, something in between two devices or on the network. If it's a fail closed piece of hardware, if that hardware dies, if the hub loses power, if the sniffing computer dies, if something happens to that piece of hardware, then that connection is going to be broken. So in our case here with the GNS3 topology, if this hub was a fail closed type of hardware, if this died, then that means that this connection would be down. And you might be thinking, okay, what really is the consequence of that? Well, the connection is down. Probably some network admin is going to come running and see what's going on. If you already own the network, if you are in charge of the network, if you're the company's network engineer, this is fine. That's going to be you. If your tap is not supposed to be there, you don't own that network, this could be a bad thing because then people are going to start looking through the wiring closet, they're going to start looking through the ceiling, trying to find why this connection has broken. Okay. So what you want to buy is you want to buy something, a piece of hardware, and you want to look in the specs and see if it is fail open. Fail open means if this piece of hardware dies, if it loses power, then the connection will still be on. Packets and frames will still go from one side to the other. Right? Fail open. Most of the expensive pieces of gear, the expensive NIC cards, expensive sniffing boxes, do fail open. So there is not a problem here. Things I've seen in the field are shuttle boxes with the Intel NICs, the Intel Pro 1000s. You could do like quad Intel Pro, quad port Intel Pros. There's two slots in most of those shuttle boxes, so you could do two of them. You could run the in-dace NIC cards, gigabit, 10 gigabit taps. So you could dedicate a shuttle box, have SSDs, and just throw it somewhere hidden or something. You also have standalone sniffer boxes that people sell. These can also be network forensic boxes, guidance software, network forensics, that type of stuff. You could also have gigabit taps, regular gigabit taps, like what you see here. This is made by Dualcomm. It's pretty cheap. I think it's like 150 bucks. I mean, basically it's a switch and port 1 is mirrored to port 5. So whatever goes in port 1, in or out port 1, it's going to be copied to port 5. Right. Now obviously on this particular box, you're going to have to connect your own computer or something to port 5 to actually capture the traffic. This just mirrors the traffic so it flows out of port 5. You're going to need to connect an extra piece of hardware to this guy so that you can make sense of that information. Right? So we know what gear we need to use to tap stuff, but where do we actually put this tap, right? So I already said if you control the network already, you can pretty much mount your stuff anywhere you want. You can actually mount the darn thing right in the rack if you wanted to. It's not a big deal. You could dedicate a port on the switch to be a span port. All a span port is a, if we have a port switch right here, and it's got 3 ports. What a span port is you could designate one of these ports to copy information from another port. So it's like a redirect, basically. You could say all the information from port 1 gets copied over to port 3. And then you plug your laptop or your computer down here and you happily sniff away. That's if you control the network. Now, of course, if somehow you broke the password and you didn't control the network, but you broke the password to the switch, you could also do this as well. On the Cisco routers, you also have a span VLAN that you could do, and you could send stuff out like VLAN 666 and send it to a remote unit. Right. And as I said before, if you don't control a network, you're going to have to tap into the links. That might involve breaking connection. If you have access to the roof, you might be able to splice the cable, put in a couple extra keystones, splice the cable, make some ends. This is where splicing and making cable or, connecting it up is a very useful tool or very useful skill to have. Wireless portable boxes hidden in the ceiling. They don't have to be that big. A shuttle box can be easily hidden anywhere. We haven't talked much about wireless taps, but if you're tapping the wireless, that's another ball game in itself. We may have a talk about that. But at the latest DEF CON 22, this guy used cats and dogs to help tap wireless networks. And basically you put a GPS collar and a Wi-Fi device on his cat, let it roam around the neighborhood, and he found Wi-Fi access points. Also on a dog, he dressed up his dog as a service dog. And the service dogs sometimes have those little backpacks that they wear, and you can stuff whatever you want in the backpack. So he put a little pineapple Wi-Fi router to do man in the middle from that service dog. And it works out really well because you're not supposed to pet the service dog, so it's, it can basically go anywhere at once. All right. Any questions about how to tap the devices that we use in tapping? We've got this dual-com gigabit tap. That's really cool. There's also another one. If 100 meg is just fine with you, there's something called the throwing star, which is basically a hub. The thing with that is it will go half duplex, and it is only 100 meg. And if the guy's paying attention, he might wonder why his 1 gig connection went down to 100 meg. But, in most cases, it will work as well. Okay. All right. So before you actually start your scanning and attacking, you probably want to do some type of searching on the network that you're trying to get into. Once we're assuming that you don't have access to the network, you're trying to do some type of penetration testing. Okay, let's see. Adrian has a question. Do you have a permanent tap running at work, or do you turn the switch span on or off? At our place, I don't know if we have a permanent tap running. We could. The problem with having a permanent tap running is if you're capturing all the time, that's a lot of information. And it can be used in a lawsuit if the other company finds it. So if you're going through discovery, they might ask for all that information, and that could be a very bad thing. Versus if you don't have a tap running, if they do the discovery, and you just go, well, we don't capture that information, so there's nothing for us to give you. So it's a double-edged sword. Uh, it's probably easier just to turn a switch port on or off, or you could designate a VLAN for sniffing, and then do what's called RSPAN, remote span, for Cisco switches. It kind of depends on different things, but here we do not run permanent taps because there's a lot of other things in the network that's keeping track of you. So, there's a blue coat, there's proxy servers, there's lots of stuff that's keeping track of websites and emails and stuff like that. And someone just pasted in that hackpad link that I pasted in before. All right, so thinking like a bad guy, you want to do some type of reconnaissance on your network or on your target before going in, just before slamming in a box onto the network. You just want to see like kind of what's going on. I pasted in a link to this DEF CON 19 talk, Steal Everything, Kill Everyone, Cause Total Financial Ruin. It was probably one of the best DEF CON talks I've seen because this guy gets paid to break into places, and it's pretty amazing the tricks that he uses. It's more geared on the physical penetration side, so he physically breaks into places. You can play that later, but it talks about the mindset that you need to have. You're going to play dirty. Expect the bad guys to play dirty, right? But in our case, if let's say we want to go into a company, let's use eBay for example. I don't hate them or anything, but that was just the first name I thought out of the blue. One of the first places I will go to, in addition to Google, Pastebin is a very good website, pastebin.com, and Pastebin is used by various people to post up raw text. So I know some of you may have used Imgur, which is an image posting utility. You just post up pictures, or Instagram is another one. You just post up pictures and everyone can see them. This is the same concept except with text, right? So if you're searching for some text that someone might have put on, you might search for ebay.com, right? And let's see, you might find like there's a lot of eBay websites and stuff like that. So we might be interested in like an eBay email address. I don't know if we'll actually find some. So, mail.ebay.com. So you may actually find an idiot employee that got caught at like a Starbucks or whatever, and hackers have posted up their email address. You'll find there are certain paste bins in here that will have thousands and thousands of email addresses, and these are things that spammers will put up. And the reason for that is spammers will post these long lists of emails for someone else to clean up. So they've harvested emails from God knows where, and there's things like quotes and weird symbols around it, and they pay these people to clean it up. So they just want the name at certain email address. And these lists can be then sold for decent amount of money, assuming you have lots of email addresses. So this is the first place I want to go to. You may also want to search for like network, the word network diagram and the name of the company. I highly doubt eBay will have their network diagram floating around on Pastebin, but you never know, right? Right, so you do a little bit of searching on Pastebin. You do a little search on Google Maps. There's a nice search called Shodan, shodanhq.com. This is like Google except finding vulnerable devices. So other people have searched through for this. And the way this works is, if we think about webcams, the baby monitors have an IP address slash something. It could be like admin.html. It could be a well-known port. And there are services and people out there, all they do is they mass scan the internet for these vulnerable devices. And the bad thing about baby monitors is a lot of people leave the default passwords on because, they just want to buy it and throw it in on their network. So this could be something. Also, you could scan for open VNC ports. VNC, open authentication, no password, and you'll be amazed at what you could find out there. Right. Another thing is you want to be looking at employees. So not only just stuff you can find in Google and Pastebin, you want to have a directed listing of people that work inside the company, because that could give you information to possibly do social engineering to get into the network. Could also give you some insight into possible passwords that they use. If this guy works for a company and he has a whole bunch of weird hobbies, maybe the password's going to come out of that. LinkedIn has an interesting thing. It's called InMaps, INMAPS. It's kind of a beta service that they have. And what InMaps is, I have this open up for my name here. It basically takes all your contacts and visualizes them out. So I'm here in the center, and I can't zoom in anymore on that one. But you can see that I've got a lot of blue, a hell of a lot of blue, and a hell of a lot of red, right? And some green up here and some purpley stuff, right? So what it did is it churned through my contacts, and it figured out that all of this blue is my former employer, DreamHost. So all these people related to DreamHost. So there's a cluster of a whole bunch of people, right? Down here, this is people I know from Tom's Hardware. Over here, Skolta, Narvik, and basically all my CCIE buddies are over here. And this green, what the hell is green? This was the hosting provider that I used to work for, right? So if you're able to pull up InMaps from someone else, I don't know if you can or not, but if you can do some type of visualization on employee and figure out who they know, then that gives you a foothold. You could do a spoofed email and say, hey, I'm a friend of Glenn. I'm looking for this information, that type of stuff. All right. You could also spoof an email. Let's say a network admin just recently left. You could spoof an email from their former coworker and say, hey, we're trying to get into this router, and we're looking for the documentation. Do you happen to remember the admin password for that Cisco router? Stuff like that. I know it sounds cheesy. No one should ever fall for that, but you would be surprised. Right? Any questions about this part? Thinking like the bad guy. We're just giving you some ideas. This is not a detailed discussion on how to do this, but just to get some thoughts in your head on how you could kind of start looking at things. Okay, let's do it. Let's dive in. First, we are going to teach you all about ifconfig in Kali Linux. So how to take an interface down and up. This is all through command line. We're not using any weird, stupid GUI here. We're going to OG this, set IP addresses and masks, and I'll show you how the GUI will fight with the command line in terms of setting the IP addresses. So make sure everything is up, your GNS3, your VMware, all that good stuff. Your VMware should be all green. Open up the console window to R1. Show IP interface brief. And right now your fast 00 should be down. If it's not down, that's okay. We're going to set an IP address on that, and we're going to bring it up. So interface fast 00, you guys know how to do this. IP address all ones, and make it a /24 mask. And let's change the MAC address. How about that? MAC address of AAA.AAA, basically all A's. That way it'll make the Wireshark easier to see. And no shut that guy. Right, so IP address all ones, MAC address all A's, and no shut. Very simple, very easy. We're going to go over to R2. Same concept here. We're going to interface fast 00, IP address 1112, MAC address all B's. Oops, didn't like that. Let's do all A's and then make the last one a B. There we go. And we'll no shut that guy as well. And you'll do a gut check. Ping all ones from router 2 and you should get a good ping. Okay, so here we're just verifying that the interfaces are up. We put an IP address and we ping from one side to the other. Nothing too crazy just yet. Now what we're going to do is we're going to start Wireshark on this link. So it doesn't matter whether you click on R1 or R2 side. I'm just going to right click on R1, that green dot right there. And you're going to click on Start Capturing. And then just click OK. Nothing too crazy happens yet because you have to go back, right click that link again and start Wireshark. Right, you're going to see traffic going in between. We've got some this keep alive, not a big deal. We have some CDP, not a big deal. You may see a 192.168.30.1 or something like that. That's the VMware inside of there, so I wouldn't worry about that. Right, so how many of you see traffic on your Wireshark going from router to router? Okay, great. And if you were curious, this Dropbox LAN sync discovery protocol, that just means if you have multiple Dropbox enabled computers on the same interior network, that they find each other and they sync up without hitting the internet. Okay, you're going to keep this Wireshark open. That's perfectly cool. Go over to your Kali Linux. If it's at the password screen, it's the reverse of root, so it's T-O-O-R, Tor, or however you want to say it. Normally Kali Linux inside of VMware, it's going to start off with a very horrible resolution. So you might want to click on Applications, System Tools, Preferences, and then System Settings. And then just change the display resolution. So double click on displays. You can see it's 800 by 600, which is crap. And I'm going to change it to, it's still crap, but 1024 by 768 and apply. A little bit better. All right, so with Kali Linux, normally what you would be doing is you would be going up here in the upper right-hand corner. Upper right-hand corner, you should see this two computer icon. That's kind of the network connections thing that you have inside of Windows. So what you want to do is, if you right click on that and click edit connections, this is the GUI way of editing your local area connection, right? So you should have a wired connection there. You click edit and there's things to what the hell? There we go. That was loud. Okay, So what we have here is wired connection. If you go to IPv4 settings, IPv4 settings, you're going to have, you can see it's set to automatic DHCP. Now on this link, there should be no DHCP set. No DHCP set. And this brings up an important point. If we go back to our diagram here, if we're assuming that this Kali Linux is tapped in and you're not supposed to be on this network, this cloud, this virtual machine is not supposed to be on the network. Now the question is, how do you know, how does R1 or R2 know that there's an attacker, that there's someone bad on this network, right? There are a couple ways of doing this. If we know that Kali Linux normally has DHCP turned on, what could we install or what could we start on either R1 or R2 to find out if there's a rogue machine on our network? Is there some service that we could start up on R1 that might help us find this guy? DHCP snooping, ARP inspection, possibly. How about just starting DHCP on R1? Right, DHCP, we could be, yeah, DHCP discover, yeah. So if we go back to our Wireshark, we may be able to see some DHCP. Oh, I think we saw it. Okay, if you go back to your Wireshark, if you type in DHCP, or actually, let's do this. I think that's it. Somewhere in your deal there, you're going to have DHCP discover. You're going to have a MAC address there. Now remember, we did our routers as MAC address all A's and then all A's and a B, right? So this is definitely a different one that we haven't seen. It's going to all F's. So we've got a device out there that's looking for DHCP. It wants an address, right? We could filter this out. If you click on these messages, we'll click on, we could filter by the source MAC address. So Ethernet to source, whatever it is, right click, apply as filter, and selected, and you're going to filter that out. I think it looks like it just filtered on Ethernet there. Let's see. Okay, you're going to have to go down here. Instead of Ethernet, I was a noob. I right-clicked on Ethernet to expand that out, go down to source, right-click on that puppy, apply as filter, selected. There we go. Ethernet.source equal, and then it'll have the MAC address there. That's a little bit better. All right, see all these discover messages flying out? And you can see some IPv6 and other stuff happening. So you can tell that a guy's in there. Another thing you could do is you could actually start DHCP on the router and then see it get an IP address. That's another way if you wanted to. Okay, so we're going to leave this up. We're going to open up terminal, and I want you to see what happens here. So terminal, you can click this icon up here. Terminal's going to open up. Now I know some of you may not be Linux guys, but it's okay, don't worry about it. We're going to take this slow. Let me just zoom in a little bit so your eyes aren't bleeding. There you go. Okay, so the basic command, if you want to get the information or you want to set something on an interface, is if, it's short for interface, if config. When you do ifconfig, it's going to always give you your loopback down here, and it's going to give you your local area network connection, your Ethernet 0 up there. If you've got some Wi-Fi, depending on your Linux distribution, it will say WLAN 0. But for now, you've got ETH0. You can see your MAC address. That looks kind of familiar. You should see that in your Wireshark. We don't have any IP addresses, which is okay. Okay. So ifconfig is basically like ipconfig. If you want to down the interface, very simple. ifconfig, the actual interface, ETH0, and the word down. If you hit the up arrow a couple times and bring back ifconfig, you can see this up arrow thing, up and down arrow, is the same as Cisco. You'll see that now the listing of interfaces Ethernet 0 is gone because it's down. And you probably guessed it, if you want to bring that guy back up, just change the word down to up. Hit the up arrow a couple times, and you'll see the interface is back. So we have router 1 set to all ones. We have router 2 set to all 1112. If I were to give this Kali Linux box, virtual box, if I were to give this Kali Linux an IP address of 1.1.1.3 in the same subnet, do you guys think I should be able to ping those routers? Assuming no firewalls or anything like that. Yes, I should be able to ping it. As long as I'm on the same subnet, router should answer a ping. So we're going to set the IP address, ifconfig, ETH0. Setting the IP address is very easy. You just type in the IP address. So 1.1.1.3. Hit the up arrow. Now I need to set the mask. So ifconfig, ETH0, netmask, 255.255.255.0. And now immediately after that, try to ping all ones and you should get a successful ping. And Control C to stop. Now if you let the pings go, they'll go. It's fine. You're going to see something interesting in about 10 seconds. So how many of you had successful pings and then you got network is unreachable? Right? Pings were working, and then for some reason, they're not. They stopped. And if you do ifconfig again, you'll see that your IP address is gone. This is where the GUI and the command line don't mix. So what's happening here is here you're trying to statically set an IP address. Right? We actually typed this IP address in. We want it to be 1113. But what's happening here is up here in the GUI, up here, that's fighting with everything. So what you want to do, the first thing you want to do in Kali Linux is you want to go up here to this icon for wired connection, right click it, and right there where the check mark is by enable networking, just uncheck that. Now a lot of people say, oh man, I just killed all my network. No, it just stops it from the GUI part of the networking configuration. You can still manually configure everything within command line. Okay, we've unchecked that box. Now we go back down here. And we can simply hit the up arrow, get back our ifconfig ETH1113, get back our netmask, make things easy. You don't have to retype that in. And now if we ping all ones, we should be okay. Right? And if you have your Wireshark window open, you'll see that everything looks pretty good. Any questions about that so far? Just a very simple setting your IP address and making sure the GUI network configuration doesn't override that. Yep, you may or may not. That's bad. But okay, whatever. All right, so you're on the network, you've tapped in. How do you find out what routers and what services are available for you to fight or for you to hack into? So Kali Linux is basically a amalgamation of different tools that you have, and the way to get to them is you click in the upper left hand corner, applications. You can actually close out your command line window there. Click on applications. Buried in there in the middle is Kali Linux. And you could spend years going through all this stuff, but for today we're going to be going down here to exploitation tools. It's 1, 2, 3, the sixth one down. And we've got Cisco attacks. And the one we're going to play with is Cisco Torch. Cisco Torch. And click on that. Nope, not found. Okay, so it'll drop you down to command line. Maybe they didn't do this correctly, but if you type in Cisco-Torch, you don't have to type in the whole thing. You could probably get away with Cisco-T and it'll finish it. And you hit enter, it will give you all the different command line options. It's kind of like -help. Now you can see kind of looking through this, it'll scan for telnet, it'll scan for SSH, SNMP, all types of wonderful things. If you do -A, capital A, it will combine all of these together. And you simply give it an IP address or a range that you want to check. Very, very easy. So in our case, we want to take a look at router 1. This is not going to be too exciting because nothing much is running on router 1. Cisco Torch capital A 1111. It's going to churn through its deal. It'll take a little while, but if you take a look at Wireshark, you're going to see something interesting here. There's some cool stuff happening here. See some ICMP. You saw TCP probably try to hook into TCP going to port 22. That was to Telnet. You saw SNMP get request. You saw it get hit with NTP. Look at this. You saw it sent out TFTP, so try to connect on TFTP. Yeah, saw some ARP there. Saw some more TCP. That TCP to port 80, what do you think it was trying to connect to there? It's trying to HTTP, yes. And also TCP to port 443, it's trying to connect to HTTPS. We go back to the command line, and you could basically see it says nothing found, nothing interesting. So, okay, it's scanning for HTTP. Do you think if I turned on HTTP server on R1 that maybe the scan will find something? Well, let's try it out. So go back to R1. This is kind of scary. I know most of you probably haven't done this before, but IP HTTP server turns that web server on a Cisco router. Who here has actually gone to the HTTP server on a Cisco router or a switch. Yeah, it's crap, isn't it? And it's there, right? Okay, so now R1 is running HTTP server. Very easy. You go back to Kali Linux, hit the up arrow, Cisco Torch, -A, all ones, hit that enter, and you're going to see something really awesome happen. So now it's going through Telnet, going to the SNMP. It rips out the web page, the HTML. So it found it. Right there. All right, that's the web page. If we take a look at the Wireshark, all of that was right here. That was the GET request. Basically, give me the web page. And then all this information here. Now, if you're looking at the Wireshark, what you can do is you can right-click inside of all these acts. You can right-click on that and follow the TCP stream and reconstruct this. So follow TCP stream, and you can see this is the HTML of the web page. Which is pretty nice. I wonder if we could hit it from within Kali Linux. If I open up a browser, I should be able to. Okay, so I'm opening up a browser inside of Kali Linux. I should be able to type 1.1.1.1, and there is my really awesome Cisco webpage. For bonus points, where is this web page stored? Who knows what directory it is on the Cisco router? Oh, someone emailed me in, or messaged me in Gmail. Flash. Yeah, it's pretty broad. It is in Flash. All right, I'll leave you guys to think about that. You could Google search for it. So that is the wonderful web page. Whoops. Okay, looking back at this Cisco Torch, you saw that it will scan for SNMP, right? -U. So that dash capital A finds it. So we could start SNMP on this Cisco router and have the scan find it on purpose, right? We can go to R1 and we could do SNMP server, do question mark if you don't know what's going on here, community, SNMP server community, set up a string. I'm going to do something very bad. We're going to use the string community. This is the string that you're going to see in a lot of the Cisco books, either public or Cisco. And I'm going to do something double bad, which is RW, which is read write. Oh man. And I'm not going to put an ACL on it, which means anyone can hit that read write community string. One of the first things you should do if you ever get hired on anywhere, look for SNMP community public and kill it. Change the name. If it's RW, change it to RO. Make sure SolarWinds isn't doing any funky stuff, because you'll kill that if you change the community string. But just be careful there. All right, go back to Kali Linux, hit the up arrow, scan it. You're going to see SNMP come back with a hit right there. SNMP found. somewhere buried up here. Cisco by SNMP found. And if you look back up here, you're going to see somewhere, oh, you're going to have to clear out your filter. It was a little confusing at first. Go back, and somewhere in here, you're going to see that SNMP fly out. You could filter it out by SNMP in the filter box, hit enter, and that's what it was. Get request, and the get response came back. If you look at the data, you'll see that SNMP, community, public, yeah, look at that. And the data that came flying back. And then clear out your filter. That way you don't confuse yourself later. All right, so Torch is pretty good. It finds Telnet, SSH, SNMP. You found that. It's very nice. This HTTP authorization vulnerability scan, you're not going to get a hit on that. That's an old bug. I don't think you should ever hit that now, although might be surprised. You could also do a dictionary attack. If you have a text file with passwords, you could do -B, and it'll try to log in with different passwords and stuff. Yep, by default, it's going to be SNMP version 1. Okay, any questions about Cisco Torch? Cisco Torch, very nice utility if you're just dropped in on a network, you want to just scan the whole thing for Cisco devices, and it's fine. Now, since it's scanning on normal ports, I'm going to assume that, I mean, Telnet's Telnet, should, usually on port 22. It should basically work with other devices as well. All right, so that's pretty fun tool, but now that's just recon. That's not, you're not actually doing anything crazy with that tool. You're just trying to find stuff. The next one up is Yersinia. Yersinia is something that's been around for, man, quite a while, like 6-7 years or something like that. And this is mainly attacking layer 2. You can shove a bunch of CDP down the router's throat, make it think that there's all these other devices out there. You could do crazy things with VTP and DTP. You can make VLANs disappear. You could add VLANs. You can do crazy stuff with HSRP. This is probably the one I like the most, because with HSRP you can force yourself to become the active router on that link and basically get all the traffic on that link, or all the traffic, all the forwarded traffic. So it's a very nice utility. It's attacking layer 2. Later on in another session, we're going to run a program called Loki, and Loki attacks layer 3. So OSPF, EIGRP. I don't know if they've actually built the EIGRP in there yet, because there was some copyright stuff with that. But attacking RIP and MPLS. MPLS is the cool one. You can make your own tags and impersonate stuff and all that. But Loki, it has to be built in and added into Kali Linux. It's not in there automatically. Okay, Yersinia, and we might do Mac off, but for now we'll do Yersinia. And the way to get to Yersinia is Applications, Kali Linux, Exploitation Tools, Cisco Attacks, and Yersinia. Click on that. It's going to give you command line stuff. I know it looks kind of scary, but no worries. Just type in Yersinia in the command line, space -G. This will bring up the GUI. When you get really good at this, you could do the command line, but for now, we'll use the GUI. Hit enter and you're going to get this. Click OK on that box. Now it looks a little intimidating at first, but don't worry about it. It's okay. Now, if you click on launch attack, it's upper left hand corner, you can see you have different tabs up here. You have CDP, DHCP, 8021Q. So all that stuff about double tagging and breaking out of the VLAN, that comes from this. 8021X, DTP. So if you want to become a trunk forcefully, you can do that. HSRP, ISL, MPLS, all types of fun and wonderful stuff in here. So we're gonna take a look at CDP. Don't do the attack yet. Don't do anything yet. Let's just keep router 1 on top here. And on router 1, show CDP neighbor, and you'll just get one neighbor, right? R2. Go back to Yersinia. Click the second option down here, flood the CDP table. Flood the CDP table. And click OK. You're going to see a bunch of crap in this center window here. All right? Bunch of stuff in that center window. And wait like 2 seconds, 3 seconds. And then click exit here to stop it. Go back to R1 and show CDP neighbor. And your CDP table should go on freaking almost forever. Now it's kind of obvious that you're getting attacked here because the platform says Yersinia, but you can spoof packets to say whatever you want. Oh my god. Okay. Q. Okay. So how many of you were able to see all those new CDP neighbors on that link? It's more of an annoyance attack, but I guess in early routers you might have been able to like completely overload it. Right? And if you take a look at your Wireshark, you'll see that your Wireshark might have crashed. But if you filter out for CDP and you scroll all the way down to the, oh dear God, yeah, I kept going. So if you scroll through your Wireshark, you should see a whole bunch of CDP stuff in there. And if you look at the sources, all of those MAC addresses were spoofed. These were just randomized, which is pretty nice. If you open up the data part, CDP, Cisco Discovery Protocol, you'll see that software platform. That's where the Cisco router got the information to list it out like that, where it says Yersinia. All right, so that's a CDP flood. Let's do something else that's fun. Go back to Kali Linux, hit the up arrow, Yersinia-G, start Yersinia again. Click back on launch attack. Launch attack. And, oh, we're running out of time here. Thanks for letting me know. The fun one is HSRP. Become the active router. Now we're gonna have to do something before we actually start this, because we want to actually start HSRP first and see what happens. So you could just kind of keep Kali Linux up like that. We're going to go into R1 and we're going to start HSRP between R1 and R2. Now HSRP here. I don't know if they're teaching HSRP in CCNA, but if you don't know it, that's fine. We're going to do the 10-second version here. We're going to go into interface fast 00. Stand by your HSRP group. Right? You're going to give it an IP address, And we're going to say the HSRP IP address for this link is 111.254. Let's say. And we're going to say standby 1 preempt. Now, if you don't know what those commands are, don't worry about it. I'll explain in just a second. On R2, we're going to go to interface fast00, standby 1, IP 111.254. So it's going to belong to the same group in IP. And standby 1 preempt. So both sides are running HSRP. Router 1 became the active router. So if router 1 goes away, router 2 should take over. So the way this works, if you've never played with HSRP before, is we've got 2 devices. Possibly connected to a switch or something, and this is breaking you out to, other devices, right? So if router 1 is the active router, what's happening here is we've got a computer down here, and let's say his gateway is set to .254. When he goes out to the internet, the traffic's going to go this way, right? If this link dies, what happens is router 2 over here detects the break, detects that, hey, this guy isn't responding to me anymore. I think I'm going to take over. And then it's going to take over that IP address, and you're going to start sending information out that way. There's some gratuitous ARPs and stuff like that, but basically what happens is now instead of sending stuff out to A like an idiot, you're going to send it out the other way. With Kali Linux, what we're doing is we're basically putting another box on this link. We're forcibly becoming the active router and forcing everyone to send information to us. All right, let's see if we can get this to work. Go back to Yersinia. Become active router. Become active router. We'll click OK. And you can see here it says source IP. What is your source IP? So it's fine. We'll make it us. 1113. 111.3. Click OK. And magically, you're going to see something interesting happen on R1. If everything works out correctly, you're going to see a message on R1 that just reads fast00 HSRP. It just changed from active speaking. This guy is still standby. Okay, that's fine. Now if we show standby on router 1, look at that. It is now in listening mode. Standby router is router 2. Inactive router 311. I don't know why it actually says 311 because we typed in 1113. But basically what's happening is that guy came in with a high priority 255 and took it over. So we booted R1 away from being the active router, and we've taken over that link. All right? Any questions about that? Right? And cancel that. And down here where you see this information, all of these attacks can be customized. You can go into edit mode and change these guys if you wanted to, and basically cook your own packets, which is pretty nice. Okay, we'll exit out of there. And yeah, we are at the 70-minute mark. So any questions before we wrap it up? And you'll notice that Loki is not built in here. We actually have to add Loki to Kali Linux. But if you read up, Loki was a Black Hat talk a couple years ago. It was a pretty nice one, but it allows you to send awesome information into layer 3 routing protocols. The HSRP would be used for a man in the middle. Yes, that's probably what you would be using it for. So after you get all the traffic, you sniff it and you would send it on its merry way back out. Or you could rebroadcast it back to the regular HSRP active router, or the router that it's supposed to go to. And everyone would think that everything's normal. Okay, well that was Wireshark Wednesday session number 3. We went over Yersinia, we went over Cisco Torch. It was a reconnaissance tool. We did our Kali Linux inside a VMware workstation, connected it up to GNS3. A pretty easy topology. What we can do later for future episodes is we'll make this topology a little bit bigger, maybe add 3 or 4 routers. And of course, you can start Wireshark anywhere. You could put multiple clouds in different places. But for our purposes, if you're just starting off, this is just fine. Just have the 2 routers, a hub, breaking out to a cloud. All right, thanks everyone for attending. Let me stop this recording, and as usual, we can talk afterwards.